It's teardown time, and you can't, it doesn't even fit in frame. Okay, we're going to start with the box. The LNB probably gonna leave that for later. So, as I said in the previous video, I gotta sit down. I want to basically take apart everything about this internet setup. So if you haven't watched that video, that's where I actually introduced what's in there. I can't open the box because it's gonna hit the camera. Hold on. I have to do it very carefully. Nice. It is a two-way ViaSat or Eutelsat or whatever, technically ViaSat, internet router, and we also have the LNB, as you have seen. And yeah, I want to take everything apart, everything, including the power supply, because in the previous video I did say this is incredibly huge, like a comically large power supply, and I want to know why does it have to be this huge. So we're gonna start with that. Then we are going to take apart the modem, and finally the actual LNB. I have all my tools here. As you can see, I've marked out the area, the FOV of the iPhone, so hopefully I'll be able to keep everything in frame. I do want to do it without damaging anything, because I still intend to use this setup for, well, I want to say its intended purpose, but we're not actually going to be getting internet with it. I'm very surprised that the power supply actually comes with a bolt or a screw instead of just being glued or welded shut. However, I cannot seem to actually open it. I don't want to damage it, as I said. Is there another bolt there? Oh! Okay, there are actually two hidden ones. I was looking in the middle, thinking there might be a hidden one, but there's actually a pair of them. Look at that. I'm not sure if I should blur out the serial number. I don't think I should. Maybe I should on the modem, so you can't snitch on me, and the MAC address, but I think I already leaked that in the previous video. Oh, actually, speaking of the previous video, wait, let's talk about that later. There we go. That's the power supply. I should be careful with those capacitors because it has been used. Actually, let's see. Let me try something. I'm going to turn off the overhead light. You can see I bought the stupid streamer light, the circle light. I'm turn it off so you can see better. If we do get some spark from this. Oh, it actually did. Did you see that? Oh, that's scary. This has to be like 24 hours turned off, so I think they are parallel because it doesn't. Okay, well, I'm not sure if you saw the spark, but it definitely did shoot a spark. So it's a good thing I discharged it. So be careful whenever taking apart anything that handles actual wall power, AC power. The capacitors may stay charged for quite a while, as you have just seen. So yeah, there we have it. I'm not sure what I expected to find. Will this entire thing come off? Yes, it will. Okay, this is actually really interesting that normally you would not have a power supply made to be taken apart. Normally they would prevent you from taking it apart. I think this says it's from 2012. I'm not sure what these markings mean. There's 7 and 12. So does this mean 7th month of 2012? Anyway, this is the power supply. It's not very dense. The components are not very densely packed, so that explains why it's so giant. I thought there would be like some huge transformer, but yeah, this is just a switch mode power supply by the looks of it. Look at that, that's nice. It is a big, what I presume is shielding for the bottom of the circuit board. So unfortunately we are not gonna be able to see exactly what's in there. Listen, I don't know how power electronics work. I don't know how any electronics work, so I wanted to take it apart just out of curiosity. So there we have it. That's the power supply. So let's put it nicely back together. But yeah, I'm really happy with this, how they made it to be. I thought it would be older, since pretty much all new electronics are not made to be opened up ever. So this is nice. This is really nice. Okay, so that was the power supply. Now let's open up the actual modem. There it is. Again, probably not going to fit entirely within view. This is the back panel. We have the LNB connector, Ethernet, then a USB port, which I'm actually not sure what it's used for. and then our power input. I figure this is going to be pretty easy to take apart. I see only 2 bolts. I do fear that taking apart the LNB is going to be very, very difficult. And we may compromise its waterproofing, but that's not a big deal. Really hard to get everything into view. I keep complaining about the iPhone's field of view. It's like weird, when you switch to video, the camera's field of view just narrows down. But I can't complain too much, the video quality is much better. It really does not want to come apart. No, I can see inside. I'm looking inside right now. I know you can't see anything, but you have to trust me. I'm looking inside right now. There is nothing that looks like it's holding onto the plastic. I just noticed something. The front is coming open. And there is some tab here, so I wonder if we have to push on that. Because, yeah, it looks like that's exactly where the point is that's holding onto it. So I'm gonna try pushing in there. I think we might have got it. There may be another tab like that over here. Okay, we are going to inspect it and see if I broke any of the plastic tabs. What's the best way to frame it? Probably like this, right? There it is. And it actually looks like I did not break anything. So yeah, you can see there are like these plastic tabs that you have to push onto. So across, so you have the 2 bolts there, 2 screws, and then diagonally separated you have the 2 plastic tabs that you have to push onto from the outside while pulling on this. So if you're gonna be taking this apart for like maintenance or cleaning it, that's what you gotta be careful about. Let's see if we can take off the back plate. Okay, this has 4 screws. Are these heat sinks? I guess these would be like very rudimentary heat sinks for these 2. I guess it's the processor. This is unfortunate, or maybe it is not. Maybe okay. Let's take out the PCB. I probably should have been wearing an anti-static armband. I'm already seeing some interesting things. Actually, no, those are just LEDs. Never mind. I thought it looked like internal antennas. Okay, I gotta say one thing. Not sure how well you can see it. All of the screws are the exact same, so it doesn't matter. So this is very nice for disassembly. Just like the power supply, which also was surprisingly easy to take apart. Normally you don't see that. There's a pin header here. That's nice. Here's the metal back plate. It has a reset switch. I did not even notice that, but yeah, there is actually a cutout. I'm just blind. So here's the motherboard. I'm now going to switch the iPhone into 4K mode, and actually you will notice something. If you take a look where I made these markers to mark the FOV, I'm gonna switch to 4K now. Look at that, the FOV of the iPhone actually gets slightly wider when you switch to 4K. It's interesting. But the reason I'm switching to 4K is so that now I can do a digital zoom across the PCB and I don't have to like weirdly hold it up. There's the annoying reflection of the circle light, so I'm just gonna wiggle it around. We're going to focus on some things. Actually, I can hold it up to the camera and I will get an even better resolution. Yeah, as I was saying, there are some interesting coaxial test points, it seems, test connectors. There's a header here, which doesn't seem to match anything, so this looks like there's some unused slot. We're gonna go over this side shortly. I just kind of looking at the I/O. So there's some test connectors, and then there is an entire pin header. Do you see it over here? So I wonder how difficult it would be to flash the firmware of this. Obviously that's not something I can actually do on my own, but kinda interesting. I need to take this apart, so this is the actual RF portion of it. Now, let me take a better position here. Remember, this only deals with the down-converted frequencies, as we saw yesterday, only in the UHF range. this is not actually outputting the 20 to 30 gigahertz. That's what the LNB is actually doing, converting from low frequencies up to high and from high up down to low. Now we need to take this RF shield off. I'm gonna have to probably use a knife for that. Luckily it's not a soldered one, you can see it has a cap that we can just sort of peel away. We can just bend it back into shape, it's gonna be fine. I bet it's not even necessary for the correct function of the board, but you know, it's to be compliant with radio regulations, making sure it does not transmit excessive interference. Haha, look at that. So this should actually have PSK modulators and demodulators integrated. I'm already seeing some really interesting circuitry, so I'm going to now take the phone and give you a closer look of the RF path, probably starting at the RF connector. Right, so I've been going over this, kind of scribbling down what I found on Google. This is not the actual schematic, this is just so I can orient in whatever the hell this is. But I think I have it mostly figured out, at least the RF section of it. It's not really visible there. I'm not sure if the phone is gonna focus. The RF path actually comes here from the connector. Now the autofocus is gonna be off. It comes from the connector and is immediately split by what effectively is a bias T, but at higher frequencies, right? You have a capacitor, which only lets in the higher frequencies, and then you have an inductor, or in this case it's two capacitors and ground in the middle, whatever. I just simplified it as a single capacitor. That's these ones over there. And then we have an inductor. So that's how it's basically split immediately into two paths. So this is one path at the lower section and then another path at the higher section. Obviously, as you can imagine, one of these is for receive and one of these is for transmitting. In this case, the upper one is RX, the lower one is TX. So let's start with the upper one. There we have another inductor, a much beefier one. So I think, judging by the giant trays there and the big power inductor, I think this is what the actual bias T is. So this is where the DC 30 volts comes in. Then we have another inductor here in the RF path going through a filter. So this is the, as I said, this is the receive path. So this is where the like below 1000 megahertz signals would go. This is where the actual downlink from the satellite will go. And we have another filter here. I gotta say, I have not seen this style of filter before. I think this effectively, I'm not sure, I think these blocks act as capacitors. And then, so this would act as a capacitor and this as an inductor. And it's sort of alternating. I'm really not sure, maybe both are inductors. And then through more passive components, it goes into this ADRF 6850, which I googled is an IQ demodulator, 1 gigahertz, up to 1 gigahertz IQ demodulator, which goes further through this, whatever this is. So we would have the two IQ rails here, so it probably has to somehow keep those balanced or whatever. It goes into this chip, which I'm not sure if you can read the name of. We sort of need to adjust the angle. AD9600. I'll zoom out. And that is actually an ADC, an analog to digital converter, running it up to 150 million samples per second. And that's what demodulates, or not demodulates, that's what converts the IQ from the demodulator into digital data, and that is fed into a Cyclone 3 FPGA. Probably it's fed into it. I think this board has multiple layers, so I don't actually see all of the connections, but you know, I mean, here we have the ADC and right here is the big FPGA, so you know, it's pretty easy to imagine that they are connected together. And the TX path works in a similar way, except with, you know, reversed components, so that it also goes through a filter, a more familiar microstrip filter, but this does basically confirm that the transmit stage, I'm sorry, I just reduced the brightness. This does basically confirm that the transmit stage is operating at a higher frequency, above the receive stage. So I'm not sure why I could not see any transmit activity when I was looking with the SDR. But there again, there we have a filter. I'm not sure if this is a band pass or a high pass. Then we have an amplifier, and we are actually going backwards. So the amplifier, where is my thing? So the input is on this side, the output is on this side, right? Because this is the transmit stage, it's reversed. The power flows like this and then out of the connector. So this is basically just a simple LNA. I was reading something else. This is an ADL 5602. This is the 8045110, and I could not find the datasheet for this. But assuming that this is basically just a mirrored path of the receive stage, this would be like an IQ demodulator, I guess, or IQ modulator. This has got to be some sort of a modulator, since then you have a big RF path going from it into the amplifier. And of course, before it, again, this strange network of components. But here, with the most conveniently labeled transmit DAC I've ever seen. It literally says TX DAC on it. I have it over here. It's an AD9743 BCPZ. And that is the digital to analog converter. It says up to 250 million samples per second. So that probably as well is then just connected to the FPGA, which is over there. Here's the RAM for the FPGA, 4 megabits, I think. Not sure what this component is. But seeing as it is under its own metal shield, and if you look at the bottom, this is where it would be. It has some capacitors under it. I think this may be a crystal oscillator, maybe an oven control, OCXO. I'm not sure if this is how they look like. I don't think I've encountered one before, but it would make sense because you don't want it to vary in temperature at all. So it would make sense if this is an OCXO that you would keep this metal part of it, or the inside of this metal part, at a constant temperature. I'm not sure. Maybe I'm just making things up. We can see another RF test connector here, and then this header. So I think this is how the FPGA is programmed, or I guess this is how they would update the programming of the FPGA. I'm not sure, but this definitely looks like it's meant to be some sort of a header, and there is no breakout on the outside of the case. And then the rest, because this is where the RF ends and this is where the digital communications begin, the rest I really have no idea. I do recognize this as something to do with Ethernet, which, I mean, it was not difficult to figure out, right? Not sure what these chips do. I could probably look it up, but the issue is, without knowing the markings of these, and I'm not going to be removing the heatsinks, I would just break them. I'm not sure I would be able to really tell you much about this. I'm just trying to give you views of the different components, so you can sort of see exactly what we are working with. What is this? Y1, so this also looks like a crystal. Y4, 12 megahertz. What is this chip? Let's take a look at its marking. Yeah, here we have the mysterious header, pin header. So this looks like it was supposed to be exposed on the back plate, and the back plate is exchangeable. So it's possible that some variations of this modem actually had this exposed. I guess this would be for programming or just reading some telemetry from it, like, you know, your signal strength and stuff like that. Maybe for industrial settings where you actually need other devices to read the statistics from this. You have the reset button, the USB connector. Let's see if we can trace its data path. Looks like it's going inside on some inside layer, because I don't see the actual traces anywhere. But it would probably just be going into one of these two chips. So this, I think this will be the SoC, or maybe that, because this is just an FPGA that's there clearly just to handle the very high data rates that it needs to deal with for the radio communications. But once it actually gets to the normal, quote-unquote, normal computer type stuff, the data rates are not really that high, right? It's like 20 megabits, I think, the Ethernet. So this is like the high rate. This is where the technologically packed portion of the board. And then here we have like more or less normal router hardware, router, modem, or whatever, switch hardware. I can turn it around, give you a look at that, but again, I'm not really gonna be able to see much because, I mean, I'm fairly certain this is a multi-layer board. But all of this is quite interesting. There's an unpopulated footprint there. Yeah, I'm fascinated by these networks of passive components. This has to do something with the IQ handling. Look, we found L1, the first inductor on this board, and this is actually U1, the ADC. Or is it the DAC? No, that's the ADC. No, that's nothing. That's the IQ demodulator. So that's the first. That's the U1. Not sure what this contraption is. It's like a big, I don't know, is that a diode or something like that? It says X1, which basically means nothing. There we have an LED here, which is not actually visible from the outside, so there's a secret LED. There's another one here. I wonder if that's related to the header, to the FPGA programming. Then we have a bunch of normal LEDs, and by normal I mean those are the ones actually visible on the outside, or meant to be visible. There's another LED there. Look at that, there's so many LEDs you can see. And I think that's all of them. Let's take a look at this section of the board. I think I have not really shown you that. Yeah, but that's it. That's the actual modem. And now let's take a look at the LNB, which I figure is going to be the most difficult part of this entire teardown. Very quickly before we get to the LNB, I opened my window. Don't worry about the background noise, I will close it again. But I just noticed, I don't know how I missed that before, there's an entire footprint for a second F connector that has its own unused RF path. As you can see here we have a filter, some unpopulated capacitors, and that's what this footprint is for. So this is what this will be connected to, and this looks like it's just disconnected. So I think there might have been a possibility to have a separate RX and TX path, basically. Not sure why you would do that. Maybe for like legacy LNBs that have two separate connectors. I'm not sure. But yeah, that's kind of interesting. Just wanted to point it out. Otherwise, yeah, I kinda showed you everything. So let's move on to the LNB. Okay, hopefully I got it framed more or less the same as before, because now, if I get rid of all of the garbage accumulated here, now, Jesus, this is so heavy. We're going to be taking apart the LNB, and I feel like every single movement is just going to vibrate the camera view. Look, it just barely fits in the FOV. Yeah, that's gonna be really difficult. So I'm going to start by removing the waveguide. We should be actually able to see inside this waveguide. Actually, you're probably not gonna be... I'm not gonna be taking the waveguide apart. It looks like it can actually go in half, but I'm not gonna be doing that because I'm not confident that I would be able to put it back together. As I mentioned, I want this to still work. Okay, there we go. And now we should just be able to pull this out. There's probably some waterproofing under there. Yeah, there is. There's a little seal. Okay, let's take a look in there. You can't see anything. There's Captain Tape on there. Can I even see anything with my eyes? Not really. So this is the actual 30 GHz waveguide, I guess. It has to work at both 20 and 30 GHz. You can see it's like corrugated inside. I want to see what's under these. Maybe there are bolts in there. So I do, unfortunately, have to cut these off. Obviously there are screws or bolts under there, but it does not tell me whether these are actually structural or if they are for tuning in there. And if they are for tuning, okay, if they are structural, I have to take them apart to actually lift the lid. If they are for tuning and I take them apart and I undo them, then I've messed up the tuning of the LNB. So I can't do that if they are for tuning, but I have to do that if they are was holding the... I'm gonna have to stab a screwdriver under there. Let's see if I have one with me. I have this, what looks like a nail file. That might actually be an ideal tool to get this open. Let's see if I can get it under the lid. Yes, I actually can. Okay. So we need to loosen all of this up. Wow, that was satisfying. Let's see if I can repeat that on the long side. Obviously this is going to compromise the weatherproofing of this LNB, or any LNB, so all LNBs are basically look like this when you take apart their plastic cover, although they are much smaller. But I'm not that concerned about it. As I said, I do plan to use it again, but I don't plan to use it in the rain or anything. I don't plan to have it on a fixed permanent mount. Look, it's flexing like this, so this might actually be... I don't want to take them out just to find out they were DRO tuning screws. I really don't. It says it should be PLL. There's mentions of this LNB and PLL in the same sentence. There's nothing like that with DRO, so I guess, you know, let's just hope that by removing these screws I'm not completely destroying the tuning of the LNB. I'm really hoping they would not have used DROs. I mean, it's from 2010, right? And it's the KA band. 30 GHz, you would not want to use DROs on there. Haha, and we have it, I have my finger under there. Oh, Jesus. Okay, this is it. I'm gonna do it in a cool revealing way. Okay, maybe not. I'm just going to brute force it. Okay, ready? 3, 2, 1. Okay, I guess not. I can feel some RF absorbers already. Okay, clean my hands a little bit. Clean this so the pieces don't fall inside. Bruh, what did I just see inside? What the hell is inside of this LNB? You know what? That's fine. It can be like this. There's a relay? Why is there... What? What? What is this? Is this thermal paste? Okay, I need to get this lid off. Well, that was easy. Look at that. We can't, admittedly, we can't see any of the actual high frequency circuitry right now. Unfortunately, I don't think we're gonna be able to see much. We may be able to lift this RF shield. And whatever this is, there has to be the speaker somewhere, right? Since it was beeping. Do I dare take all of these screws out? Oh my god, I'm gonna break something, aren't I? Let's see if they are a standard size. Of course not. Wait. No, that's not. It's not doing mechanical switching of uplink and downlink, right? But there's a solenoid and there are reed switches next to it. Okay, so yeah, this is both really interesting and really disappointing because I kind of want to take this apart further, but I also don't want to do it, otherwise I risk breaking it. I did not hear the LNB like clicking or anything. Go. I know some very old TV LNBs had mechanically driven the antennas inside to actually change their skew and their polarization. I wonder if this has something to do with that. It is, I mean, it is flexing a little bit. Oh, please tell me I did not just lift some assembly components, some surface mount components. There's another unpopulated, so this is an entirely unpopulated, unused branch going to the RX connector, so that tells me that maybe there is some option with the modem, because we have seen a matching unpopulated F connector there. There's probably some option to have them completely separate. This looks like it could come apart if I just remove the four screws there. Let's see, are they... oh no. I need to be careful not to get any garbage into it. You probably can hear the dog barking in the background. I don't know what else I can do. I moved completely indoors. I cannot be more indoors than I am right now. I think this is the power amplifier. This would be some RF switch or some diplexer or whatever that separates the uplink from downlink. I think this is the downlink. And this might be the uplink. I don't know. Will this just lift up? What? Is this a waveguide? Is this how it separates? Because you need to have good separation. You cannot have any of the uplink transmit power going into the downlink, even though it is like almost 10 GHz higher. Well, it is 10 GHz higher. Still, that is still a lot of power. It could probably blow some of these LNA stages. It has more bolts on it. Do we take it apart completely? Bro, if this LNB still works after I put it back together, that's gonna be a miracle. Okay, are you ready? What the hell? Like, this looks like an engine part, like it's from some internal combustion engine valve or whatever. But no, this is for microwaves. This is for radio waves. No, like, nobody knows how this works. Nobody can tell you with a straight face that they know how this actually works. They're just making it up. Don't trust them. Okay, I had to take a little break and actually try to figure things out. So I think this may be some sort of a filter, which would make some sense for it to be exposed like this. So it could be just a drop-in change if for some reason you wanted to do that. And I think this is some shutter that's moving under there for mechanical polarization switching, but I don't know which bolts I should be removing. That's the problem. There's no way this LNB is still gonna work after I put it back together. Jesus Christ. I've already pushed my luck with some KU bent LNBs, and I was very pleasantly surprised with how resilient they are, even to damage that I might have caused to the internals. But I think at this point I'm really pushing it. We already see some microwave RF section here, but obviously it's just a small part of what has to be underneath. Or is it? Because, I mean, if this is the power amplifier, this is gonna be the mixer, because we can see a crystal oscillator here. So this is the IF. So the uplink goes here, under this mysterious thing, it gets up converted to 30 GHz, sent here to the power amplifier, and the downlink somehow just spawns in here. I would expect to see like a through hole and a pin. I bet this tiny thing is the actual waveguide probe, and there's a waveguide coming up like that, like a C-shaped waveguide. Yeah, that has to be it, because if we take the RF shield, that would be on like this. Yes. Yeah, look at that. So I bet this forms the cap of a 20 GHz waveguide, and this little square is an actual monopole, or like a... This little square is the actual antenna. Let me show you, because this is actually the 20 GHz antenna. This is it, this little square, I think. And then we have a couple amplifiers. This, whatever this is, this may be actually the... I don't know, I don't care. Let's just ignore that. I kind of need to lift this. And this is probably a filter just to make sure the 20 GHz doesn't get into the 30 GHz uplink. I'm really concerned about lifting this. Let's see how strongly it is adhered to the board. Yeah, this may be actually taking it a bit too far. I'm afraid that if I lift this, I might actually just lift some of the SMD components. I don't think heating it up would do anything. Do we just YOLO it? Do we just say, fuck it? So this is clearly some RF absorber. I'm gonna start peeling it from the side, so when we get to the center where the actual sensitive parts are, there's the lowest possible amount of tension or like pulling on them. Okay, this actually is going better than I thought. Look at that. There's gonna be some RF absorber or some RF dampener. And here we have, this is probably like the main chip of the thing, right? So it looks like there are two unused paths. These are just completely unused. This is the one that's used. There will be one going, I don't know, this entire section of the LNB is just unpopulated. But this is the IF. It's a balance. Okay, so this is a balloon, right? This is a balloon, balanced to unbalanced transformer, because we have a unbalanced transmission line here. We have just one trace going in, surrounded by ground, a microstrip trace, and this has to be splitting it, right? Because it comes here, the signal goes here, half of it goes this way, half of it goes this way, and then they kind of, because this path is longer, this would be inverted phase, right? Is it how that works? I really have no idea. I'm so sorry. And then it turns it into, so this turns the unbalanced into a balanced path, and that's what this chip is working with. That's why we actually see two parallel traces, and here we have another transformer by the looks of it. Yeah. I'm kind of starting to build the picture in my mind. So if this is the cap, this is the end cap of the 20 GHz part. The waveguide is here, so it's in line with this, so this is the 30 GHz path. Goes in here, which probably is the power amplifier, since it's a big metal block. I imagine that's gonna be producing a lot of heat, so you need that. There's gonna be a probe similar to this or something like that in the waveguide. So this has to be the diplexer. This has to be what takes the 20 GHz component and sends it through that weird channel, which may actually be acting as a filter a little bit, into this. And here you actually see it's kind of tapering in there. It goes like that. And I guess the waveguide has to come like this, and there has to be some polarization. I really want to take this apart completely, but I'm not sure we're gonna be able to do that. I'm a bit concerned about this. If I lift this up completely, will it just go? Okay, I need to be more careful. I think I have to put all of this back in. Is this like thermal paste? Or is this just to prevent moisture getting in? Because if this is thermal paste and I just removed it, I might have affected, whatever, it's fine. Or it may be just RF absorber, because it looks like it's the same material as this. If I lift this, okay, let's get back to removing these screws. Let's do it systematically. We don't want to remove anything that does not need to be removed. This just adds complications, adds failure points, things that I will forget to assemble. Is there some other screw holding it? It feels like something is still holding it. Okay, oh, okay. So this section of the PCB just lifts up. It doesn't care. I'm just taking a closer look at everything. Oh no, I think I see how they assembled it. I can see that the PCB actually has a cutout here, so it would, when they were putting it in, this was already in there, or maybe they put it there after that, but this was separate from the PCB. They put it in, there was a square hole in there, then they put what presumably is the power amplifier in there, and then they made solder bridges. That's how they attached it to the PCB, and that's what these plastic covers are protecting. I'm gonna try lifting this one on the 30 GHz path, because I'm not messing with desoldering that. It feels like it's glued in. I cannot lift this, but I mean I can see it already, that there's like that this is kind of floating in there, and it has solder bridges. Oh no, so obviously I cannot stay this apart without actually disrupting the 30 GHz thing. Oh no, I really wanted to see the mechanical switch. But this is clearly held in there, together, somehow attached to the waveguide. And as you can see, there are obviously bolts under there that we cannot access with the PCB on it. But we can take the PCB off with this being connected, which in turn is attached to this, and you know, we kinda get into a feedback loop. So yeah, I think it's gonna have to end here. And if I noticed this, I could have saved a lot of effort removing all of those bolts. Yeah, that's really disappointing. Maybe I can get like a broken unit at some point, because I just noticed there are actually two RF paths. Why would there be two paths? And one is going through a different... Maybe one is for like power monitoring or something, I don't know. If we measure across it, it's around 6 millimeters. I don't know. But if this is the 30, I mean, if this is the 20 GHz path, then what would this be? This clearly looks like it's the downlink, because we have the probe here too. This looks like the normal circuit that you would see in any other LNB. Okay, so let's take a closer look at where we got, since we are not going to be getting anywhere further. I mean, it's not that bad. We are basically seeing all of the RF circuitry that there is to see. I think I said that I thought there's gonna be a lot more on the other side, but it turns out this LNB is just more integrated than I thought, because this chip basically seems to be doing everything internally, combined with this microcontroller. So, let's see. Here we have the IF port, so this balanced transmission line, or differential transmission line, is what's working with the low frequency, so like, I don't know, 0 to 2 GHz. I still don't know what frequency the uplink is. Considering what I saw in the modem, it should be above 1 GHz and below 2, I don't know. But it goes directly into this chip, and I could not find a datasheet for it. I'm gonna try to give you the view of it. I could not find anything saying what this chip actually is and what it does. There may not be a public datasheet available, unfortunately. Then we have the microcontroller that actually drives this, so you can see a bunch of digital, you know, communication lines going into the ATmega or XMega 324A4 microcontroller. And you know what, I actually looked up the datasheet of this, and this pin header, that's actually exposing the programming pins, so it will be quite easy to reprogram this, but because we don't know what communication protocol this uses, and you know, the rest of the LNB, there wouldn't be much use to that. Here we have the buzzer, so that's what was actually making the sound. You can see the sound port there on the side. It's a low profile buzzer. So that's what actually was making all the noises. So clearly this has to have some functionality of reading the power level. I mean, there's gotta be some digital communication going on, because the modem is telling, I guess the low frequency communication signals would go through the inductor together with the DC. And there would have to be some decoder chip, or it goes directly into the microcontroller, and the microcontroller is decoding the commands coming from the modem. I don't know. There's this chip, I did not look it up, but that seems to have something to do with the power supply, so probably not that important to the digital communications. And there's another chip here. This does not look good. I hope I did not I hope I did not pull some component out. It looks like there never was any component. You can actually see the imprint of the solder blob, so I did not rip out any components, luckily. I also tried looking up the model of the actual power amplifier, or whatever this assembly is. So that has to contain the power amplifier, but clearly, seeing as there are two RF connections going to and from it, it must be doing something else, and there's quite a bit of other components. There's a thick trace, so this is probably the power. I wonder if this is some solid state switch that just is made to handle high powers, because it's bridging from, or maybe it's ground, but you can see there's a transistor on it. That's probably controlled by the MCU. Interesting, interesting. Is it really interesting? I don't know. I think it is. A gold-plated whatever this is. I mean, it's probably not actual gold, but you know, it looks kind of cool. I keep accidentally lowering the brightness like this instead of zooming out. Yeah, so unfortunately, I was hoping to take this further, but without the datasheet of this, we can't really do much, and without desoldering this, because it's, as I said, sort of floating. It's not actually one part with the PCB. You can see there, this is where it's visible the most. You can see that there's clearly a gap in the circuit board over there as well. It just goes all around it. Even there, look, you can see on the corner. So I would have to desolder all of these tiny connections, including like 20 and 30 gigahertz ones, which would be extremely difficult to get back without, you know, attenuation and just breaking the physical properties of it. So unfortunately, I'm not going to be able to show you the mechanical part of the polarization switching, which is what I think this does. I'm now going to take some high-res photos of this PCB and the modem PCB and stitch them into one big image and put them in the video as well, so we can have a closer look. But yeah, I guess that's gonna be it. You know, in some ways this has been surprising. I really thought it would not be this integrated, where there is just one big monolithic chip that all of the RF connections go into, but yeah. If we could find the original firmware for this, or the original code, I don't think that's gonna happen without like contacting the engineers who worked on this. It's probably deleted by now, it's from 2011, there's the date code. It would be cool to actually take full control of this and like connect it to an SDR or something, but I mean, we can still connect it to an SDR, we just need the modem in between to actually run it. But that's gonna be it for now. I'm gonna try putting this back together and seeing if it still works, and if it does, there are some experiments that I want to do with this setup. So there's gonna be one more video on this, and then I don't know, we're gonna move on to some other topics. But yeah, for now, thank you for watching as usual. Subscribe if you want to see the third video, and I'll see you in the next one.